Hello and welcome to the old Fliers. We have been following the Boom Overture development for over a year. Boom Overture hopes to be Concorde's successor. Supersonic commercial travel by air ceased when Concordes were grounded on October 24, 2003. Since then, the opportunity to cut hours from flight time has been a dream. The Qantas direct flight between Perth and London by Boeing 787-9 Dreamliner takes 17 hours at Mach 0.85. Concorde cruised at Mach 2+, theoretically cutting that time to 7 hours. Time is money, and there would be many who would pay a hefty price to save 10 hours flying time. Boom founder and CEO Blake Scholl explains the progress that is being made towards this goal.
Boom and Groupon are really the same idea. Half off flight times, right? Wow, 2025 has just been such a historic year, not just for Boom, but for supersonic aviation in general. The first civil supersonic jet made in America, XB-1, we're back. Broke the sound barrier 6 times across 2 supersonic sorties. And we proved that a small, driven team can do amazing things. We go to traditional aerospace shows and we show them a picture of XB-1, and people from the big companies say it must have taken 1,500 people. XB-1 was just 50 people. You can look at XB-1 in some ways as supersonic flight's Falcon 1 moment. But in some ways, it's more meaningful. The first 3 Falcon 1s didn't work, but XB-1 was human piloted from day one, meaning we had to be safety critical from day one. So we built our safety technology, and more importantly, we built a foundation of our safety culture that we carry forward into the airliner. We also demonstrated something else pretty remarkable on XB-1, which is boomless supersonic flight. The most surprising thing is, this is actually a software solution for sonic boom. We use algorithms from computer graphics, ray tracing, to predict the trajectory of a sonic boom and how it will refract through the atmosphere on any given day. And this drives an advanced autopilot that allows us to fly the airplane in such a way that the sonic boom never reaches the ground. Pretty cool. So it was 24 hours from breaking the sound barrier to being in the West Wing. 4 days from breaking the sound barrier to this picture, when our airplane made it into the Oval Office, and 115 days to the executive order repealing the 52-year ban on supersonic flight over the US. This blows the market wide open. And I think many, many different supersonic airplanes are now going to be possible. A whole family of airplanes, from large airliners to private jets, all flying faster than the speed of sound, making the world a more accessible place. And we're, of course, starting with Overture. This is the all-business class supersonic jet that I think all of us will get to fly on in just a few years. Overture is designed to succeed where Concorde failed, most importantly by reducing the cost of supersonic flight. Our ultimate vision is supersonic flight for every passenger on every route at fares similar to what you'd pay in economy today. But we're starting with fares like business class, about 3/4 less than was charged on Concorde. And this means a market 2 orders of magnitude larger than Concorde ever had, and just growing upwards from there. So imagine being able to cross the Atlantic in about 3.5 hours, or being able to cross the continent also in about 3.5 hours. You can leave New York at 9 a.m. and land in San Francisco at 9:30 a.m. Oh, it's just going to be great. And this is why airlines are lining up for Overture. We have $30 billion of orders and pre-orders from great airlines like United, American, Japan Airlines. And we're going to be building these airplanes, starting assembly of the first unit in about a year at our super factory in Greensboro, North Carolina. That's not a render, that's a real building, 180,000 square feet assembly line, designed to produce 33 jets per year. We're going to scale up from there. And along the way, we've learned a lot of lessons about how to do hardware development efficiently and rapidly. And the core principle is really about making hardware development look a lot more like software development. In software development, the cost of change is low, so you can iterate quickly. And classically, the cost of change in hardware is high, so you can't iterate very much. But this is all changeable. And there are two things that are key parts of our hardware development playbook. First is actually software. We embed software engineers onto every hardware development team, where their job is to look over the hardware engineer's shoulders and automate engineering workflows, automate engineering analysis, automating design. And what this means is we can ripple change through our designs rapidly and at low cost. The people who are the software engineers are great, but they don't have to know anything about hardware. They just have to be curious and ready to learn and really great at building automation. So we can reduce the cost of engineering design changes. The other piece is about iteration and hardware. And in a traditional aerospace supply chain, we're going to take 3, 6, 9, 12 months to get a part out of a legacy supply chain. Change kills you. You can't do anything if you've got a setback that long when a part needs to change. And the solution is vertical integration. So we're bringing even more of our manufacturing in-house. Ultimately, we're going to be able to build every single part that goes on the airplane at R&D scale in the same building that the company is headquartered in. This means that we'll be able to turn a part change in minutes or hours, not months. And then we can iterate in design, we can iterate in hardware, we can build amazing things super quickly. So right now, our main focus as we scale from XB1 to the Overture airliner is the engine. This Symphony engine started as an idea for an idea about 3.5 years ago. And people called us crazy. I've come to believe that vertically integrating propulsion is the most important thing we ever did. And I think the outsourced approach to this is the one that's ultimately going to be seen as insane. The Symphony engine is very unique out there on the market. 40,000-pound thrust class engine, designed for sustained high-power operation, unlike subsonic engines that are a burst of power for takeoff. An ideal balance between a big enough fan to be quiet for takeoff and landing, but a really meaty, powerful core that gives us the transonic performance for boomless cruise. Boomless cruise would not be possible without our own engine. And as we get further into this, we're discovering this engine can do many other things as well. We're going full vertical on the engine. Not just making our own engine, we're making our own engine parts. And we're controlling our engineering, our manufacturing, and our test infrastructure. When you use someone else's test infrastructure, you have to schedule a test window months or years in advance. If you're early, you can't capture the time savings. If you're late, you're screwed. But we are building our own supersonic propulsion lab just 30 minutes from our headquarters and from our manufacturing in Denver, Colorado. We can test any time of day, any day of week, anytime we want, allowing us to move super, super fast. So, like I said, not that long ago, Symphony was just an idea. But right now, we're building the first engine, and it's coming together rapidly. People say a startup can't build a turbine engine. Hold my Jet A. We'll find out pretty soon who's right about that.
Recently, Overture's proposed engine, Symphony, was tested at Georgia Tech University in a program to test the performance of fuel injectors.
We are here to test our single nozzle rig, which is a fuel injector that's installed in a single nozzle test section, where we can study the fuel's ignition as well as stability for the flame. Hi, I'm Nishant Jain. I'm a senior propulsion engineer at Boom. A burner in a jet engine has fuel nozzles, which is an important part of the engine where you gotta mix the fuel with the air at the right time and in the right distance, and you have to ignite it and stabilize the flame. Boom and Georgia Tech has been partner for this study. We have a single nozzle rig test facility that was commissioned at Georgia Tech's Combustion lab. This is the place where I started my graduate school, and Professor Zinn, he's one of the pioneers in combustion who taught us combustion. We are basically starting a fuel nozzle and combustor design from a sheet of paper.
Boom trying to go and build a supersonic commercial plane is having to really innovate on the combustor side. We're doing their single nozzle testing. So looking at things like flame shape, emissions, flame stability, ignition, which we're doing today, all these things we can do here, as well as using more cutting edge, world-class diagnostics to really understand the thermodynamic and fluid dynamic conditions inside the combustor.
The XB1 is proof of sustained supersonic flight, such considered small steps. Just curious though, the sonic boom was Concorde's Achilles heel. Concorde was not permitted to overfly continental America at supersonic speed. So, why would a company seeking to develop a supersonic commercial aircraft name itself Boom? Comment if you have a theory. Support for our channel most appreciated.